We might have had a breakthrough. I've had a program that does brilliant things. We can now use a potentiometer to alter the delay. So it's a very simple program that does the digital hello world, the blinking LED. But we can adjust the time delay using the potentiometer, and it's a very simple bit of code, and we're going to experiment with that as well, just to see if my naming theory from the last video is right. So we'll have a look, well, now. So here it is. Here's little Mr. Blinky LED there, obviously, because he's flashing on and off. It's the blue one, and it's showing up purple. It's partly because they emit a certain amount of infrared, and the camera's particularly sensitive to infrared, unlike our eyes. But okay, right, that's as slow as it goes. If I turn it that way, it's going to get faster. To the point that, yeah, the delay is so small, it's basically on half power, but yeah. The shutter speed is set to 30 at 1/30th, so it should be picking up without too much weird strobiness. That's that. That's really dead simple. Well, I'm really pleased we can do that, because it means if we set up a chase, we're not set with a fixed delay. We can then put, oops. It's all right, just kicking the tripod. We can set up, a chase with a delay on it, and if we make that a permanent fixture, we can put a potentiometer on the front with speed control on it. That'd be really exciting. So we'll now look at the code, because that's even more fun, because we're going to play with that and do some experiments. Okay, so here's the code. It came from the Arduino site itself, so try not to nudge the tripod too much. It's free, it's in the public domain, and we've just copied it onto here, the Arduino sketching box thing. I've forgotten what it's called now. Anyway, come back to it, and it even tells us what it all does. So, analog input is what we're looking at. Demonstrate analog input by reading an analog sensor on analog pin 0 and turning off and on, or on and off even, a light emitting diode, LED, connected to digital pin 13, it says. Well, I changed that to pin 11 because digital pin 13 is connected to a on the board, and that flashes won't just annoy me. Describes the circuit here, potentiometer, how you connect up the potentiometer. Anode long leg of LED attached to pin output 13. Ours isn't, it's attached to pin 11 and therefore has a current limiting resistor of 220 ohms between its cathode and ground. Otherwise the LED might not last very long. Who it's created by and all the credits there, which is really rather nice. Right, so the setup. Int sensor pin equals A0. So that's selecting the input pin for the potentiometer in nudge camera. This case it's LED pin is pin 11, not 13 as it said up above. And then we've got sensor value equals 0, variable to store the... And now I had a minor revelation here, that the 0 value isn't a value. It says there is no value. That's my thinking. Go and find your own value, it's saying. Void setup, declare the LED pin as output, which there we are, pin mode, LED pin output. LED pin is pin 11. And then we get into the void loop. Sensor value, analog read. Look at the sensor pin. Turn LED on, digital write, pin high. Yeah, we've done that before. delay is the sensor value, the value coming from the sensor. Now, I said the other day, I think we could put what hell we like in there and it will still work, so we will. We're going to change that to goat, because, well, why not? And sensor value here will, where's delay? Have to stop being sensor value and try being a goat. Did I press, no. Is it goat with a capital G? Every time we see sensor value, we're going to change that to goat. This is just an experiment. I have no idea whether this is going to work or not. And that's it. We're now going to change the view slightly. Other way, other way, other way, other way, other way. So that we can now also see the little LED, pointy thing, little LED flashing away. And we're going to watch what happens when I send that. We don't want to save it. Ting, 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 ting. Ooh! We've made a mistake. It says sensor value. I need to change that to goat. And try again. I'm not going to save it. Can we still see that LED flashing? Flashing faster and faster and faster? That's brilliant. It works. So we have learnt that up here, when we set this value, this is the name. It doesn't have a value. It doesn't have to be anything particular. You can call it what you like. Goat equals go find your own level, basically, or go find your own value. That 0 seems to mean. We'll check that, because we'll put goat equals 500. And we can then, I can't find the upload, there it is. Well, save it. Ding, ding, ding. And now it still works. That's interesting. I didn't expect that. Maybe that's... We'll try 1,000, because 1,000's 1 second if it's working in milliseconds. I don't want to save you. Go away. There's a bike outside. It's a Chinese bike. And that's gone up. And it still works exactly the same. I'm just wondering quite what that value does. Okay, so that's perhaps that theory thrown out the window, but we do know that we can name that value whatever we want. But we're still stuffed as to exactly what the 0 means. Okay, we'll have a look and see what we can find out and come back to that at a later date. I've got another one backed up that, well, I haven't backed up and written it yet, that does things involving the serial read as well. And there's a bit of maths in it about mapping, which is quite useful for dimming and stuff like that, because the input is 1024 step, but the output can only be up to 255, I think. Yeah, 256, it'd be 0 to 255, which is actually 256. Okay, right, we'll come back to that soon. Bye.